Thank you for joining me in this meeting. Um, First question we would like to solve today. We do have floor system, which is shown in this figure. Before moving forward, I would like to highlight few points you have to be aware with. This label will represent a column, and this line as well as this line, as well as this line, as well as this line, or these lines represent something called beams. And the area covering the whole floor system is the slab or floor. That makes sense? The floor system of the hospital shown, so looks like this floor is for a hospital, consists of 4-inch thick reinforced concrete slab. So your slab has a thickness equal 4 inch, and the concrete slab is supported by concrete beams. So these lines, which are representing the beams, these beams are 15-inch by 30-inch cross section. We need to figure out the total load assigned to the beam on axis BB. So looks like we do have axis called BB. Remember, we have circles here. One of the circles labeled with B, so looks like we have another circle on the other side with the same label B. So on this axis, we have a beam, this beam. This is the meaning of the beam on axis BB. To locate, because we have many beams. If you look, we have 1, 2, 3, 4, 5, 6, 7 horizontal beams and 1, 2, 3 vertical beams. So we have many beams. How to locate your beams? I give you the beam on axis BB and the column on axis 2, 2 with BB. So keep in your mind, beside the axis BB, we have another axis 2, 2. We do have another circle here with label 2. So the intersection of BB and the 2, 2, we do have this column. That makes sense? So I need to understand, I need to calculate how much load coming from this floor system to this beam with the pink color on axis BB and the column located on the intersection of BB with 2, 2. Keep in your mind, we have many columns. This is a column, this is a column, this is a column, this is a column. We have many. So I need only the column at the intersection of BB and the 2, 2. Before starting and before moving forward, I would like to remind you, if we start with the dead load for slab, if you do have a slab looks like this with a thickness TF, the dead load of this slab, I can say the dead load can be the thickness of the slab time gamma concrete, and this value will be pound per square feet or PSF. This is what we covered last time. And the load on the beam, I'm talking about dead load. I'm talking about the weight of the element, slab or beam. For beam, your beam looks like this. We have B, we have T. If you multiply the dead load of the beam will be if you multiply B by T by gamma concrete, you can get the load bound per foot. That makes sense? Bound per foot. This is for the dead load on the slab. This is the dead load on the beam. We covered also last time the value of the live load. For the live load, you don't need to do any calculations. Just open this table and based on the function of the building, I can tell you how much is the live load as a value bound per square feet or PSF. That makes sense? So the live load is related to the slab. How much? Based on the value from this table. Also, we covered before, if we do have floor system, and this floor system has beams, these lines represent the beams this way, or maybe we have also this way. I would like to remind you, for example, this beam is supporting part from the floor from center line to center line. What you mean by center line and center line? We are talking about this beam right now. So the next beam is this one from this side and this one from the other side. So between each two beams, we are going to divide this distance, and draw this center line. This is the meaning of center line between the beam and the next one from this side, between the beam and the next one from the other side. So from this center line to center line, we have this area of the floor will be assigned to the beam under consideration. This is the first one I would like to review with you because we covered this last week. What is the area assigned to each beam? Go ahead and draw center line between the beam and the next one from this side and the beam and the next one from the other side. If you would like to talk about this beam, which is called edge beam, this beam will have an area assigned from only one side. If you draw the center line here between this beam and the next one, we don't have anything from the other side, so the only area assigned to this beam will be this one. That makes sense? If we would like to figure out the area assigned to a column, keep in your mind your floor system will be like this. We have a column here, we have a column, we have a column, we have a column. So whatever the numbers of columns do you have, if you are talking about this column, for example, so go ahead and draw between this column and the next one, divide the area or the distance in between. Between this column and the next one from the other side, divide the distance in between. From this column and the next one from the right, divide this area. From this column and the next one from the other side, from the left, divide this area. You will find the column is determined by four center lines from the four sides. So this area from the floor will be assigned to this column. That makes sense? And if you remember, I told you this corner will have area from this side and from the other side here. So the area assigned to this corner column will be only this one. If you look to this corner, this edge column, from center line to center line to center line, so this area will be assigned to this column. And this column called, if you remember, edge column. And this column is called corner column. And this one called interior column. And we can conclude the interior column is supporting more load than the edge column, than the corner column. Anybody has any question regarding these concepts before starting to solve our problem? Let's start. What is the sequence? What are the steps to solve this kind of problems? Because we should have one like this in your exam. I will start first to figure out how much dead load on this floor system. How much dead load for the slab? How much dead load for the beam? For the slab, the value of the dead load will equal T floor time gamma concrete. The thickness of the slab, which is given here as 4-inch thick, because it's an inch, I will divide it by 12 to be in feet. Gamma concrete is a constant number, 150 pound per cubic feet. So the value I think will be 50. Yes, 50 pound per square feet, or PSF. This is the value of the dead load on the slab in general. On this floor system, the dead load value for the slab, the weight value for the slab is 50 pound per square feet. For the beam, the dead load of the beam equal P time T time gamma concrete. There is very important point you have to understand here. If we are talking about beam, this is B and this is T. The B is given as the smallest number, given as like 15-inch. The value of the T is given as 30-inch. But we have a little hint here, or a little trick. Keep in your mind, this beam is connected to the floor. This beam is connected to the slab, which is 4-inch thickness. So if you put here B like 15-inch and divide it by 12 to be in feet, that's right. If you put here T of the beam as 30-inch and divide it by 12, it's not accurate. Do you know why? Because right now I considered this thickness of the slab to be counted for the dead load of the slab. Now you are going to count B and this T, which is the total area of the beam. That means we have a part here which is counted 2 times. This part of the concrete is counted 2 times. One with the slab, and now one with the beam. So this is the reason why I said your calculations were, I'm not saying it's wrong, but it's not accurate. So what should I do? It's very simple. Just to go ahead, the T of the beam will be considered only this part, which is 30 minus 4, 26 inch. Why did you do this? Because I don't like to count this part two times, one with the slab and one time with the beam. So I will consider this 30 as 26. Then multiply it by gamma concrete, which is 150 pound per cubic feet. So the value of the dead load of the beam is 15, 26, will be 406.25 pound per foot. That makes sense? So I figured out the value of the life load. I'm sorry, the value of the dead load on the slab and on the beam. The next step, how much is the value of the life load? The value of the life load will be only located on the slab. How much? We don't have calculations. What you need to do just to go back to your problem, review what is the function of the structure, which is hospital. Open your table for one, look for the hospital. Here you go. And based on the hospital, I can figure out the value of the life load. Here is the category of the hospital. We have three values. If we are talking about operating rooms and labs, it's 60. If we are talking about patient rooms, it's 40. If we are talking about corridors above first floor, it's 80. So it's not um, it's the specific part of the hospital is not mentioned here, so it's up to you. We can assume we are talking about patient rooms, so the value of the life load is 40. PSF or pound per square feet. I'm assuming it's patient rooms in this hospitals. So far, so good. One more time. I didn't answer the question yet. I did not answer the beam on axis BB or the column in axis 2, 2 and BB. I did not answer the question yet. What I'm trying to do, I'm trying to figure out how much did load on the slab, how much did load on the beam, how much life load on this floor. This life load without calculations. What you need to do, open the table for the life load based on the function of the structure. I can locate or I can figure out how much life load we need to consider. Does that make sense? Let's start to see what we need. We need beam on axis BB. So I will start my calculations. Beam on axis BB. That makes sense? And I will go back to this sketch. Where is the beam on axis BB? This is the beam with the pink color. So I will say this beam has another beam on this side. So between this beam and the next one from the top, I can draw here center line. From this beam and the next one, I can draw here center line. So the area assigned to the beam on axis the BB will be this area. That makes sense? It will be this area. So anybody in this meeting can tell me how much is this width? Go ahead and write it in the chat if you have a number. How much is this width? Any help? Thank you. Yes, 10 feet. Correct. Thank you so much. Guys, keep in your mind, we are given a dimension here from this axis B to this axis C, 30 feet. But the 30 feet covering the three spacing, so each spacing will be 10 feet. And the next one, we have another 30 feet from B to A, covering the three spacing. So these beams has a spacing 10 feet from each other. If you divide this 10 feet with the center line, so I will have here 5. And I will have here another 5 feet. So the total width of this area will be 10 feet. And the total length of this area will be 80 feet. The total length. I'm talking about the area with the green hedge. The total length will be 80 feet. The width will be 10 feet. So the beam under consideration, which is the beam on axis BB, this beam, has an area assigned to this beam. This area assigned from the floor to this beam on axis BB has a width equal 10 feet and a total length equal 80 feet. 40 plus 40. So what is the total dead load on this beam? Will equal the value of the dead load coming from the slab, which is 50, multiplied by the area assigned to this beam, which is 10 feet by 40 feet, plus what is the value of the dead load coming from the beam, the value of the dead load coming from the beam, which is 406.25 time the total length of the beam, 80. The total length of this beam will be 80. Then I can find out the total dead load on the beam. The total value of the life load on this beam will equal the value of the life load on the floor, which you got it from the table, 40, times the area assigned to this beam, which is 10 feet by 80 feet. I have a mistake here. This area is 10 feet times 80, not 40. Sorry. So this area equal, I'm sorry, this total dead load equal 50 by 10 by 80 plus 406.25 times 80. So the total will be 72,500 pound. And the total life load on this beam will be 40 times 10 times 80 will be 32,000 pound. So the total load on this beam from the floor system will equal 72,500 plus 32,000. So the total will be 104,500 pound. So guys, just to give you a hint, step by step, this 50, which is the value of the dead load coming from the slab, is pound per square feet. To convert it to load pound, we have to multiply it by area assigned to this beam. Keep in your mind the value of the dead load coming from the beam is 406.25 pound per foot. To convert it to pound, we need to multiply it by the total length of the beam. So this is the reason why the 50 multiplied by area assigned to the beam and the 406.25 multiplied by the length of the beam. This is the length of the beam. Your beam with the red color on axis BB. For the live load, the value of the live load coming from the table is pound per square feet. Must be multiplied by area assigned to this beam to convert it to pound. Once you get the total dead load on the beam and the total live load on the beam, we can add them together, dead load plus live load, to get the final or total load. That makes sense? So your answer is divided to two parts. The first part is a general part, which is covered here. How much is the dead load on the slab in general? It will be the thickness times gamma concrete, and your value will be pound per square feet. How much is the dead load of the beam is B times T times gamma concrete. For the given B and the T, B is okay. For the T, we need to subtract the thickness of the slab to avoid any duplication. So I used the 26 instead of 30. And this dead load is pound per foot. And the value of the live load on the floor coming from this table based on the function of the building. This is in general. Once you get these values, then let's start to focus on what exactly the required. Beam on axis BB. Based on the sketch, I will draw my center line, and hatch the area assigned to this beam. So this area looks like 10 feet width and 80 feet length. And the 80 feet length is the total area, is the total length of your beam. So the total dead load on this beam will equal the value of dead load on the slab times the area assigned to this beam. And the value of dead load on the beam times the total length of the beam. It will equal 72,500 pounds. For the live load, the total live load on the beam will equal the value of the live load, you got it here, 40 time the area assigned to this beam, it will be 32,000. Finally, once you get the dead load and live load, add them together, and this is the total load on the beam. That makes sense? Anybody has any question? This is for the beam on axis BB. Let's start with the column on axis 22 and the BB. Column on axis 22 and BB. So I would like to clean up everything here and focus on the column. Where is the column you are talking about? Axis BB and the 2, 2. So you are talking about this column. So from this column to the next one, I will divide this distance. From this column and the next one from the other side, divide. From this column and the bottom one, I will divide this distance. From this column and the top one, I will divide this distance. So the area assigned to this column will be this one. Can you tell me what are the dimensions of this area? Anybody can tell me how much is this length? Can you? Can you write it in the chat? How much is the pink dimension? Yes, thank you. This dimension will be 40 and this dimension will be 30. So the area assigned to this column will be 30 by 40. Why 40? Because we have 20 from this side and the 20 from the other side, so the total will be 40. Why 30? Because we have here from this side 15 and from this side 15, so the total will be 30. So I can say this column will have this area assigned to this column. This is 40 feet by 30 feet. So what is the total dead load from the floor to this column? So the total dead load will be the 50 pound per square feet multiplied by the area assigned to this column, 30 feet by 40 feet. I'm talking about the area or the total dead load coming from the floor, from the slab only, because the beam, we need structure analysis. So we will not count this one at this moment. So the total load coming from 50 times 30 times 40, it will be 60,000 pound. And the total life load from the slab to this column will be the value of the life load is 40 times the area 30 by 40. So the total will be 48,000 pound. So the total load will equal the total dead plus the total life equal 60,000 plus 48,000 will equal 108,000. I did not count the load from the beams. I counted only the load coming from the slab. We don't like to make it more complicated because the column is supporting beams and we need to do structure analysis to figure out the reactions coming from these beams and to find out the loads on the column. So that's enough for this course. How to figure out the total load on a column? It's very simple. Figure out how much is the area assigned from the floor to this column. Then the dead load from the floor or the dead load from the slab multiplied by this area, the life load from the slab multiplied by this area, add these two values together to get out the total load on the column assigned from the slab. Let's do another example and repeat what we did. This is the question from the exam last semester. We are talking about floor system of the office shown, and we have a slab with a thickness 6 inch, and the beams or the joists are 10 inch by 20 inch. We need to calculate the total load assigned to beam on axis 1 1, the beam on axis 2 2, the beam on, I'm sorry, the column on axis 2 2, and the BB. So I don't care about beam on axis 1 1, beam on axis 2 2, column on axis 2 2, and the BB. I will start in general. What you mean? How much is the dead load? The total dead load, I'm sorry, the value of the dead load on the slab equal the thickness of this slab time gamma concrete. That's it. How much is the dead load on the beam? Equal B time T time gamma concrete. How much? How much is the life load? No need to do any calculations. Just the value of life load LL on the floor, and your floor is office, so I can open my table. So I need to answer these three calculations first before moving forward to what exactly the required in the problem. So the thickness of this floor is 6 inch. If you go back to the problem, it's 6 inch thick. So 6 inch divided by 12 to convert it to feet, multiplied by 150 the gamma of concrete. So the value will be 75 pound per square feet or PSF. The value of the dead load of the beams, since the beams are 10 by 20, 10 is the value of B, 20 is the value of T. So if you multiply 10 by 20 inch and the inch, divide them by 12, divide them by 12, and multiply them by gamma concrete 150, your calculations, I will not say it's wrong, but it's not accurate. Do you know why? Because right now we have this beam which is 10 by 20 inch. And this beam is connected to the floor slab, which has thickness 6 inch. If we already used 6 inch to figure out the weight of the slab, so I considered this weight. Now if you count 10 and 20, that means you are considering this total area. That means we have multiplication, we have, I'm sorry, duplication of this area. So this area is duplicated. In your calculation, you counted part of the concrete 2 times. So your calculations will not be accurate. So the best way to consider this 20 as 20 minus 6 will be 14. So this 14 coming from, you subtracted from 20, you subtracted 6. This is the correct and the more accurate calculations. So the value will be, we have 10 divided by 12 time 14 divided by 12 time 150. I got 145.8 pound per foot. And I will open my table for office building. Where is the office? Here you go. If you do have office use, the value will be 50. That makes sense. I think this is the only office we do have. We have another office here. Yeah, well, yeah, it's the same. The office building will have life load equal 50. So the value of life load will be 50. Just a number. No calculations. 50 pound per square feet or PSF from the table. That makes sense? Then I will start thinking about what is exactly you are looking for. We are looking for beam on axis 1, 1. Where is axis 1, 1? Here is 1. So we should have another circle here called 1. So the beam on axis 1, 1 will be this beam. That makes sense? This beam has another beam just after. So I will divide the distance in between to be center line to center line. So the area assigned to this beam will be this area. So what is the total length of this area? And what is the ladle width of this area? So the total length will be 32 plus 32 plus 32 plus 32 plus 32, 32 times 5 will be 160 feet. How much is this ladle width? Can you help me? How much? What do you think? The total width of the area assigned to this little beam. Thank you. Yes, it's a 3, not 5. It's a 3, not 5. Do you know why? Just look. It's a 3 feet, yes. Can you look to this 30? This 30 counting from this to this. How many spacing? One, two, three, four, five spacing. So each spacing will be 6 feet. If you multiply 5 by 6, we'll get the 30. So the width of for the distance from this beam to the next one is 6 feet. So the distance between the edge beam on axis 1, 1 and the next one is 6 feet. So half this distance will be 3 feet. That makes sense? This is the key. You have to pay attention how the dimensions are given. You need to figure out what is the dimensions of the area assigned to your beam. Then you can start. So the total dead load on the beam equal the dead load coming from the slab, which is 75, time the area assigned to this beam, which is 160 times 3, plus the dead load coming from the beam, 145.8, time the total length of the beam, which is 160 feet. Total length. I can get the total dead load. 75 times 160 times 3 plus 145.8 times 160. I got 59,328 pound. How much is the total life load on the beam? It's very simple. the value of the live load here, which is 50, multiplied by the area assigned to this beam, 160 times 3. You can get the value. It will be 24,000 pounds. Then you can add this one to this one to get the total. To get the total load on the beam, you need to add 59,320 plus 24,000. It will be the total will be 83,320 pounds. That makes sense? This is for the beam on axis 1, 1. We have another beam which is on axis 2, 2. Where is axis 2, 2? The axis 2, 2 is this one. 2, 2. So we are talking about this beam. This beam should be here as well. So this beam will have from center line from this side and the center line from the other side. So this is the total area assigned to this beam. The total length of your beam, as well as I mentioned before, it's 160 feet. How much is this ladle width? Is it still 3 feet or it will be 6 feet? This time it will be 6 feet because we have 3 from this side and the 3 from the other side. So the total width of this area will be 6 feet. So the total dead load on this beam will be 75 times 106 times 6 feet plus 145.8 times 160, the total length. And the total live load will be the 50 times the total area assigned to this beam, which is 160 feet by 6 feet. You can get the total. So what is the total load assigned to this beam? Add dead load plus the value of live load. Does that make sense? So when I'm grading, to be honest with you, when I'm grading these calculations, first I need to see these values because all students must get the same numbers. And if you have a mistake here on this one, if you use the 20 instead of 40, it's okay. The second one, I would like to see what is the area assigned to each beam. If I see something different than these numbers, that means you did not calculate the correct area assigned to each beam. The last part of this problem, what is the total load coming from the slab on the column 2, 2 and the BB? So I will remove all of these area assigned and look to the column on axis 2, 2 and the BB. This BB and the 2, 2, I'm talking about this column. That makes sense? So this column with the above one, we will divide this distance. Between this column and the below one, I will divide this distance. Between this column and the right one, I will divide this distance. Between this column and the left one, I will divide this distance. So this is the area assigned to this column. Can you tell me what are the dimensions of this area? It's very important. Be careful. I think the vertical dimension will be 32 feet because we have 16 from this side and another 16 from the other side, so the total will be 32. I think we have 15 from this side and another 15 from the other side, so the distance will be 30. That makes sense? So the area assigned to this column will be 30 by 32. So how much is the dead load from the slab on this column? So that the dead load on the from the slab on column will equal the value of the dead load from the slab, which is 75 times the area assigned to this column, which is 32 feet by 30 feet. So this value will be 75 times 32 times 30 equal 72,000 pounds. And the value of the live load from the slab on the column equal the value of live load is 50 times the area assigned to this column 32 by 30 will equal 48,000 pounds. So the total you can add 72,000 plus 48,000, it will be 120,000 pounds. So guys, it's very important to see in your calculations what is the area assigned to your element, whatever beam or column. The last example I would like to cover today is this example. It's the same idea, but we are talking here about the beam only. We are talking about the assigned to the beam, no column. So I will start first. What is the total or what is the dead load on the slab? Very simple. Thickness time gamma concrete. The thickness of this slab is given by 5 inch. Divide it by 12 times 150. One of the mistakes you can do here, you did not divide by 12. We cannot multiply 5 by 150. It's wrong. Different units. So the value will be 62.5 pound per square feet. What is the dead load of the beam? Which is P times T times gamma concrete. Keep in your mind, it's very clear here. The beam dimensions are given by 16, which is this one, 16, and by 30, which is the total one, 30. Because this is your beam. And this beam is attached to the slab, which is 5 inch thick. We already counted the thickness in the weight of the slab. We cannot count it one more time with the beam. So I have to subtract the thickness from 30. So I am going to use the B is 16 inch divided by 12. The T will be not 30, but it will be 25 inch divided by 12. This T I'm gonna use is 30, the given 30, minus the thickness of the slab, which is 5 inch, time gamma concrete 150. So the value will be 16 divided by 12 time 25 divided by 12 time 150. I got 416.67 pound per foot. How much is the value of the life load? The life load of this floor. I need to open my table. We have theater lobby. So the function of this building is a theater lobby. So open your table. Look to the theater lobby. Here you go. We have this one is theaters and the lobbies. So the theater lobbies will be 100. And that makes sense. Looks like we have many people in the theater. So the value of the life load will be 100 pound per square feet. After we are done with the dead load and the life load in general, okay, let's consider one beam. I will consider this beam because this one is continuous from this side and continuous from the other side. So what I can say, this beam and the next one, I will divide this area or this distance. This beam and the next one, I will divide this distance. So from center line to center line, so this is the area assigned to this beam. What are the dimensions? How much is this width? How much is this length? This length is very clear, is given by 20. And this width, we have 8 feet spacing between the beam and the next one. So we will have 4 from this side and 4 from the other side. So the width will be 8 feet. So I can say the beam you are talking about will have from this center line to this center line this area. The dimensions on this area, this one will be 8 feet and this one will be 20 feet. That makes sense? Yes. So what is the total dead load on the beam? Will equal the value of dead load from the slab, which is 62.5, time the area assigned, 8 feet by 20 feet, plus the dead load from the beam, which is 416.67, times the total length of this beam, which is 20 feet. I can get the total dead load will equal 1,800, I'm sorry, 18,333.4 pound. How much is the life load on the beam? The value of life load from here, which is 100 times the area assigned to this beam, which is 8 feet by 20 feet. So the total will be 16,000 pound. So the total load will be dead plus life will be 34,333.4 pound. That makes sense? So guys, if you look to the 3 examples I solved today, you will see the same steps. But the only difference from this example and the next one and the next one, how to sketch the area assigned to each beam and each column. for this example, and this example, and this example. That makes sense? But the same steps.